Tyres, vehicle dynamics and handling make up a massive part of the performance of any race car. We're here today at Highlands Motorsport Park, and I've got Blake from University of Canterbury Motorsport to talk a little bit about the approach to vehicle dynamics they take when designing their cars. Hey Blake, so we've got your cars behind you here.
Yep, yeah, we do.
What's the general approach you're taking when you're going to design one of these cars? What sort of parameters are you starting with, and what sort of outputs are you looking for when you're starting from first principles?
So what we sort of look for at the start is our extremities. So we're looking for track, wheelbase, where we want our tyres, where we want our positioning. Centre of gravity is a consideration. And once we sort of have those parameters, you look at kind of the track that you're running. So for a Formula student competition, it's a lot of tight corners, some open straights, but the key is really high lateral acceleration cornering. So from that point, we move into the car, look at roll centres, and you start looking at your stiffnesses, so your roll stiffness, spring stiffness, and from there you can kind of start developing some geometries, working with your camber, caster, kingpin inclination, and it's kind of like a combined effort between the chassis team, the powertrain team, and sort of packaging all that within the one group.
Got you. But the thing, I guess, with this competition is the rules are so open. You've got an enormous array of parameters to choose from, and there's lots of different directions you can go. So how much of that is based on sort of building on previous experience? Because you guys build a new car each year, right? So
right.
How much is built on previous experience versus, say, starting with a blank sheet of paper each time?
I think a huge part is the transfer of knowledge. There's no way that you can design a car in 3 months without that prior experience. And it's definitely, you're definitely building upon previous years. There's no point redeveloping the wheel. The guys before have done a fantastic job, and it's all about learning off those mistakes. So, some years we see issues, some years we see ways we can improve the car, and it's just about taking note of those and making use of those learnings.
Yeah, great. So what's the general suspension layout on one of these cars? What are some of the considerations you make? I can see there both of these examples are double A-arms. So what are the sort of decisions you're going through when you're laying out the suspension, deciding where to put the suspension arms, where to put the dampers, and how to select your components?
Yep, so I mean the double A-arm is a pretty standard sort of geometry for the Formula student competition. It allows a lot of freedom. It's a really reliable setup. Once you have your rim size selected and you can kind of know your constraints, it does allow for a bit of freedom with where we're putting components. Certainly with the four-wheel drive electric vehicle that we have here, we have a lot more limitations. So with that motor mount in there, we have to be really clear of interferences and our clearances between A-arms and the moving components through the range of motion. So from that, it limits you to a range of values that you can use. So there's only so much that we can play with, and it's just about optimizing those and finding the sweet spot, really.
Got you. And what is the damper system using on these cars? I can see here this car looks like I can't see any coil springs on there, whereas this one has a different style of damper and it's got some coil springs on it. So what's going on there with the dampers you've got fitted to the car?
Yep, sweet. So we have the Olin spring shocks over here, and we have our air shocks on this car. And the air shocks was a bit of a change for us. It was something that's been thought about for a while. We kind of wanted a shock that was a lot lighter. Weight's a serious consideration for us, and so with the air shocks we were able to drop quite a lot of that weight, and it still allowed us that baseline performance that we needed. The spring shocks are a really reliable, quite a linear force, whereas the air shocks are a lot more progressive.
Okay.
So that and it also provides us with a bit more adjustability. So we've got a lot more high and low speed compression and rebound adjustability. While these do have that adjustability, we've just got a little bit more freedom there. Mm-hmm. And the weight consideration was definitely part of that.
And what is a damper like this? What's it originally designed for? Is it designed exclusively for something like a Formula student car, or is it based on something else individually?
Yeah, so these are actually mountain bike shocks, downhill bike shocks. And so we've selected ones that we think are going to be capable. We do run them at a high PSI, certainly at the higher end, not something you'd probably, not what you would run on a mountain bike. But we've found that they actually perform quite well, and they're quite well suited due to the lightweight of the vehicle and the fact that we have 4 of them. But in saying that, yeah, they are at their higher end.
And it looking at the cars, I can see a little bit of instrumentation on them. I can see some damper pots. I had a look at the pedal box before. Looks like you got brake travel. What sort of instrumentation and logging system have you got in the cars?
So we run quite a few. There's a lot of linear potentiometers in the car, just recording travel, and with the shocks we want to know what sort of loads are going through our tyres, and using those shots we're able to determine that from that. With our brake we have, and our accelerator as well, it's all electrically controlled, so we need to know where that pedal's at. Yeah, in terms of other electronics in there, we also have the GPS, the 6-axis gimbal, and all that stuff is useful for interpreting stuff after track days.
And as far as logging, how do you guys manage that? Have you guys got someone that manages the data, like a data engineer or a race engineer, or how do you deal with that when you're running the car on track?
Yeah, so we always have software engineers on hand. They're always out there with the computers plugging in, just interpreting data as we go. That live track, feedback, and it's a really important component of testing. It's certainly an iterative process. There's always software updates, there's always software changes, and it's definitely having all that recording equipment in there allows us just to be able to validate what we're doing.
The other thing I guess it's really interesting about developing these sorts of cars, it's happening in a university environment. You guys have got access to a lot of really high level of equipment and presumably processing and computer power. How do you use your simulation? How does that feed into your design? Can you talk us through that process?
Yeah, well, we're very fortunate to be in the university environment and have the resources we have available. Obviously, validation is a huge component. It's something that's often quite overlooked. When you're considering the static events of the Formula Student competition, validation in the design process is vital. It's incredibly important, and so we're using a lot of Ansys, a lot of MATLAB, a lot of SolidWorks, a lot of stuff. Depending on where we're going, there's a lot of electrical software that's being utilised. A new development for us has been utilising the Adams car software. So what we've been doing is creating a full dynamic model of the vehicle in Adams. And that allows us to validate what we're doing on the suspension side of things. So being able to validate suspension geometries is really important. It's something that goes back to first principles, and it's really hard to kind of come to a suspension geometry that provides all the responses that we want, but then also provide an improved lap time. And it's really hard to justify that. So having a computer model that we can put those inputs into, and then validated that through MATLAB and also on-track data as well, is a really important process. So.
And when you're building these virtual models of the cars, is this something that you're able to set the car up virtually and be pretty confident that that setup you've got in the computer, once you're happy with it, you can take it to the track and it's generally going to work pretty well straight off the bat in the real car?
Yeah, I mean, in an ideal world, it's always what we want. In reality, there's always going to be issues, and it's just about ironing those out and making sure that you have good procedures in place to pick up those things. Having those validations as well is really important. Being sure of what we're doing is actually, realistic in the real world. It's easy to have a computer model that gives you the perfect answer, but if that answer is not actually, reliable or not relevant to what we're doing here, then it's useless to us. So it's really important to validate things, after we've put them on the car as well. So, and with suspension that's a little bit hard, but with some of the other things it's a lot easier. With some aero we're testing in wind tunnels and stuff a lot. So, validating those Ansys, flow simulations in the wind tunnel is really important for us to justify what we're doing is the right path.
Got you. And one of the things that's quite striking when you see one of these cars is how tiny the wheels and tyres are. So from what I understand, there is a pretty wide range of options. I think tyre companies are making these tyres for Formula Student events. How wide are the options that you can choose from, and what sort of things are feeding into the decision when you're going to design a car as far as size and width and compound and brand and stuff like that?
Yep. Well, there's a huge amount that comes into them. Obviously, the tyres are a very crucial part of the car. There's no point having a fabulously powered car if it can't put the power down to the ground. In terms of tyre range, it is extensive. There's a lot. There's a lot of considerations that come into it. Even just a simple path of designing your own rims or purchasing rims. There's a few things that come into it without going too far into depth. Like frontal area is one. How it fits. Packaging with our aero. Also packaging internally with you know, in terms of these, we've got planetary gearboxes within those rims, and you've got to fit an upright and your suspension pickups around that. So having clearance is definitely a consideration. Airflow, you know, everything needs to be cool through there. So there's a lot that you have to consider. I think it's just coming down to finding that optimum for your car and where your design goals are. Yeah.
And with the tyres, I understand you guys have got access to some tyre model or some tyre information that you can build your own tyre models from. Can you just talk us a little bit through how that process works with how they gather that data and how a tyre model is actually useful for you in a simulation?
Yeah. So we get our tyre data from the Tyre Data Consortium, and that's something that we can put into Atoms, so into our vehicle dynamics software. And having that in there is crucial. You know, what we're looking at with these vehicle dynamic models is suspension. We're looking at performance on the track, but it's irrelevant if you can't put that power down, like I was saying before. And with those tyres, you know, your slip angle is a huge consideration under certain lateral accelerations, and it's something that's really hard to model. You know, you've got like a highly non-linear sort of scenario, and to model that by hand is damn near impossible. So having those models in place and being able to put you know, effectively the data from the tyres we have on the car into those computer models is incredibly important.
And from what I understand, the way they test that, the way they test the tyres is essentially a large ram on a big treadmill, essentially going down and loading it from side to side and all the different pressures and vertical loads and stuff. Right. How do you guys turn that raw data into something useful that you can put into a simulation? Are you doing the modelling yourself as far as the curve fitting and stuff, or is that something that's taken care of for you?
Yeah, a lot of that has been done in-house through some UCN boys. There's been a lot of time and thought go into those. It's definitely a pretty intensive process doing all those curve fittings. It's a huge process. There's a lot of variables, a lot of unknowns, and yeah, I mean that process is, you know, something that is, yeah, it's on the leading edge. Yeah, so the boys have been pretty well hooked into that, and put some serious hours into sort of figuring it all out, and, you know, validating what we're doing and ensuring that, you know, comparing data to other resources as well. But that interpretation, a lot of that interpretation is done through MATLAB.
Okay.
Yeah.
And one of the really striking differences I see when I look at these two cars is you've got the combustion car, which is obviously just rear-wheel drive. This car is got an electric motor on all four wheels. Yep. So one of the things that's become a pretty popular thing in recent years is torque vectoring as a strategy. Is that something you guys make use of in this? And what is torque vectoring and how can it help you?
Yeah. Torque vectoring is huge, especially for a four-wheel drive vehicle. It's something that really sets them apart. So, you know, in a high level sort of, in a high level way, torque vectoring is effectively making the most use of that vertical force on your tyre. So when you're coming around a corner, the outside tyres are going to be more highly loaded than the inside tyres. So that means that we can deliver a higher torque to those tyres without, you know, utilising that additional grip, and dropping that off on the inside tyres so that we don't have tyre slip and tyre wear. And so it's about measuring, you know, our vertical loads on those tyres throughout the track, and delivering torque to those tyres based on that. And also based on slip angle, you know, steering wheel angle. And it's something that, you know, we've been working on for a while, and it's something that we haven't quite got right yet. It's an incredibly, you know, complex process. We have been, you know, developing some basic models. So we've got, you know, like an open loop system with steering wheel angle. So based on the steering wheel angle, we're loading up our outside tyres more than our inside tyres. And that's just based on a sort of like a bias. And there's been a bit of work done as well, you know, just improving that process for future years. Definitely iterative. You know, it's had its kinks, and it's something they've been working out for a while. But when we get it right, it'll be pretty huge.
And what sort of driver feedback? I don't know if you've been in a position of being able to turn it off and turn it on and back to back it. What are the drivers' feedback? What does it feel like in the car? How much does it improve the performance for them?
Yeah, it's a weird feeling. It's a weird feeling. It's like riding an e-bike, you know. It's powering you out in funny places. But it's something that can be hugely beneficial. And I think once the drivers really, you know, start to get used to it, get some hours in the vehicle, then it can be quite powerful. It's just about changing your driving style slightly, knowing when that power is going to kick in, how it's going to pull you, you know, knowing if it's going to oversteer you a little bit more than maybe it, you know, in other situations. So it's definitely something that you want to have your drivers in early with, and keeping them on board through the process. And definitely driver feedback, like you were saying, is important. Sometimes you're going to overdo it, and they're going to tell you that, and that's important because you need to know that for the track. You need to know when something's actually having a detrimental effect, and it's iterative. Yeah.
Great. Well, that was a really great rundown of the vehicle dynamics of the cars. Thanks very much, Blake. That was really interesting.
Awesome. Cheers.
Cheers, mate.
If you liked that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you subscribe. We're constantly releasing new videos, and if you like free stuff, we've got a great deal for you. Click the link in the description of this video to claim your free spot to our next live lesson.